you remember the first time you fell in love with dinosaurs? For so many of us, it was a defining childhood moment. Going to the museum, standing beneath the colossal skeleton of a T-Rex, feeling that perfect mixture of awe and terror. We learned their incredible names: Triceratops, Stegosaurus, Velociraptor. They were the real-life monsters that ruled our planet. And then we learned the tragic end to their story, the Great Extinction. The part where a giant rock, an asteroid the size of Mount Everest, screamed out of the blackness of space and delivered a planetary-scale knockout punch to the Earth. And almost everything about that simple story is wrong. Well, not wrong, but dangerously incomplete. It's a children's version of an adult's horror film. The asteroid itself, that giant rock, was not the real killer. In fact, if you were standing on the other side of the planet at the moment of impact, you wouldn't have felt a thing. The horrifying truth is that the dinosaurs weren't killed by a rock from space. They were executed step by step by our own planet's atmosphere and geology being turned into a series of elaborate torture devices. The rock was just the trigger. The sky was the real weapon. I know this sounds like a crazy conspiracy theory. We've all been taught the simple impact story our whole lives. So right now in the comments, tell me, what did you think was the main thing that killed the dinosaurs? The impact of the dust cloud? A giant tsunami? Let's see how many of us were told the simplified story. Because in this video, we are going to deconstruct the real science of a global killer event. We will show you the 3 distinct horrifying kill mechanisms that happened in the first 24 hours after the impact, long before any dust cloud had a chance to form. We will talk about the atmospheric shockwave that flattened forests thousands of miles away. We will talk about the blinding heat pulse that literally cooked animals in their tracks. And we will talk about the most terrifying of all the global rain of fire, where the sky itself caught on fire. This isn't just about dinosaurs. This is a forensic investigation into what happens when a planetary scale bullet hits our world. The physics are the same whether it happened 66 million years ago or if it happens again tomorrow. And here is the reason you need to stick with us to the very end. After we walk you through this apocalypse, we are going to show you the incredible real-life mission that humanity has already launched to fight back. We will introduce you to NASA's DART mission, the first time in 5 billion years that a species on this planet has successfully altered the course of a celestial object. We are no longer the dinosaurs. We can fight back, and we will show you how. This is the story of the planet's greatest killer and humanity's greatest hope. To understand the real execution of the dinosaurs, you have to forget the idea of a single drawn-out apocalypse. The end of their world wasn't a slow fade to black. It was a rapid-fire sequence of 3 distinct global-scale kill mechanisms, all triggered within the first few hours of impact. This was a planetary-scale assassination, and we're about to deconstruct the first 3 bullets. First, let's set the scene. The asteroid, a rock the size of Mount Everest, is screaming through the atmosphere at over 40,000 miles per hour. That's so fast it would cross the United States from Los Angeles to New York in about 4 minutes. At this speed, the air in front of it can't get out of the way. It gets compressed, superheated, and turns into a blinding fireball of plasma before the rock even touches the ground. The asteroid hits the shallow waters of the Gulf of Mexico. In that single violent killer one, the shockwave, the moment of impact creates a blast wave, a shockwave of almost unimaginable force. It radiates outwards from the impact site at supersonic speeds. This is not wind. This is a wall of overpressurized air. Within a radius of 1,000 miles, roughly the distance from New York to Miami, this shockwave would have been apocalyptic. It would have flattened forests like they were made of matchsticks. It would have generated earthquakes stronger than any in recorded history and triggered colossal tsunamis that would scour coastlines halfway across the world. For any dinosaur within this vast circle, death was instantaneous and absolute. But this was just the opening act. This was the brute force. The next killer was far more insidious. It's a chilling thought that a single impact could cause earthquakes everywhere. Some people even believe major asteroid impacts could trigger volcanic eruptions on the other side of the planet. What do you think? Is that a plausible scientific theory or just a cool movie idea? Let us know your take in the comments. Killer 2, the thermal pulse. As the asteroid vaporized upon impact, it threw a massive plume of superheated rock dust and gas high above the atmosphere into the vacuum of space. As this material spread out, it released its intense energy in the form of a brilliant blinding flash of thermal radiation and infrared heat pulse. Think of it like the heat you feel from a giant oven, but on a planetary scale. For any living creature with a direct line of sight to this fireball in the sky, even thousands of miles away, the effect would have been horrific. The air temperature would have spiked to hundreds of degrees for several minutes. Forests would have spontaneously burst into flame. The ground itself would have become hot enough to cook animals alive in their tracks. It was a global-scale broiler. If you weren't underground or underwater, you were incinerated. But even for those who survived the shockwave and the heat pulse, the most terrifying weapon was still to come. A weapon that turned the entire sky into an enemy. This next part is what separates a regional disaster from a global extinction event. It is a phenomenon so alien, so terrifying, it's hard to even imagine. We're talking about a global rain of fire. And in our next chapter, we will show you exactly how the sky itself caught on fire. So within the first hour, much of the world was either flattened, baked, or both. The planet was wounded and burning, but the asteroid's assassination was not yet complete. The sky itself was about to become the final, most widespread executioner. The third killer was on its way. The shockwave has passed, the heat pulse has faded. For those who survived the initial cataclysm, there might have been a brief, terrifying moment of silence, a moment to look up at the sky and wonder what could possibly come next. The answer was fire. A rain of fire falling not just over the impact site, but over the entire globe. Wow, how is that even possible? How can the sky itself catch on fire? The answer lies in the debris, the trillions of tons of vaporized rock and asteroid that were ejected into space during the initial impact. This material didn't just disappear. It was thrown into temporary suborbital trajectories around the Earth. And then gravity did its job. It began to pull all of it back down. What you have now is not a meteor shower. It is a global-scale re-entry event. Every single one of those tiny particles, some no bigger than a grain of sand, hit the upper atmosphere at hypersonic speeds. The friction was so intense that they heated up and began to glow like trillions of man-made shooting stars. Unbelievable. The sky across the entire planet, day and night, would have lit up with an eerie, terrifying red glow. But this was not a light show. This was a death sentence. Each of these glowing particles was a tiny radiator beaming intense infrared heat down onto the surface. For hours, the upper atmosphere would have been heated to a temperature comparable to an oven set to broil. The air at ground level would have become scorching hot. Any flammable material, dry leaves, grasslands, forests, would have spontaneously combusted. This was the rain of fire. A global firestorm triggered by the atmospheric friction of the returning debris. It didn't matter where you were on the planet, the sky itself had become a convection oven. Any dinosaur that survived the initial blast and the heat pulse, if it was not in a burrow or deep underwater, was now cooked alive. Think about that. Not a single spot on the planet's surface was safe from this. It's a level of destruction that's hard to comprehend. What do you think would be the scariest part of this rain of fire? The heat, the glowing red sky. Let us know your thoughts below. And after the fires, as after the sky had finished its terrifying bombardment, came the final and most patient killer. The one that would finish the job. The impact winter. The fires that raged across the globe, consuming entire continents of vegetation, produced an unfathomable amount of soot and smoke. This fine black soot, combined with the dust from the initial impact, was blasted high into the stratosphere. And just like we saw with the Yellowstone supervolcano, this created a thick, dark impact veil that enveloped the entire Earth. The sun was blocked out, not for a day or a week. Scientists estimate this planetary darkness lasted for at least 2 years. Think about what that means. The world was plunged into a state of perpetual freezing twilight. Photosynthesis, the very foundation of almost all life on Earth, stopped. The plants that weren't burned in the firestorms now withered and died in the cold and the dark. This was the great filter. The herbivores, the giant plant eaters like Triceratops, starved first. With their food source gone, the carnivores, the mighty predators like T-Rex, were next. The food chain collapsed from the bottom up with brutal, systematic efficiency. The asteroid didn't hunt down every last dinosaur. It didn't need to. It simply turned off the sun. It took away their food, plunged their world into a freezing darkness, and then simply waited. It was a slow, cold, and utterly complete execution. So the three killers, the Shockwave, the Heat Pulse, and the Rain of Fire, were the brutal, violent assassins. But the Impact Winter, that was the silent, patient executioner that ensured there would be no survivors. An absolute planetary scale reset. It is without a doubt the most terrifying threat our planet has ever faced. A threat that for 66 million years seemed like an unsolvable problem. An act of God, until now. Because in our final chapter, we will show you how humanity, the tiny mammals that inherited the Earth from the dinosaurs, has begun to fight back. For 66 million years, the story of the dinosaurs has been a chilling cautionary tale, a cosmic lottery that our planet lost. It taught us that when the universe decides to throw a rock at you, you have no choice but to take the hit. The question of how to survive an asteroid impact was always a philosophical one, a problem for movie scriptwriters. There was no practical answer. Until September 26, 2022. On that day, 7 million miles from Earth, humanity did something that no species in the 4.5 billion year history of this planet has ever done. We fought back. This is the story of the DART mission. DART stands for Double Asteroid Redirection Test, and its name is a perfect, almost poetic description of its mission. NASA was not trying to destroy an asteroid, they were trying to do something far more subtle, far more intelligent. They were trying to nudge it. The target was a tiny asteroid moonlet named Dimorphos, about the size of the Great Pyramid of Giza, orbiting a larger asteroid named Didymos. It was the perfect, harmless target for a game of cosmic billiards. The DART spacecraft itself was no bigger than a small car. The mission was brutally simple in its concept, but breathtakingly complex in its execution. To fly a small autonomous spacecraft for 10 months across millions of miles of empty space, and to hit a tiny, fast-moving target that you can't even see until the final hour. In the final moments, the images beamed back from DART were stunning. The tiny dot of Dimorphos grew larger and larger, its rocky cratered surface filling the screen. And then, a final perfect image, before the screen went black. Direct hit. Humanity, for the first time ever, had successfully punched a rock in deep space. It was an incredible technological achievement. But the real question, the billion-dollar question, remained, did it work? Did our tiny spacecraft actually change the path of this giant rock? The answer when it came was better than anyone had hoped. Dimorphos's orbit around Didymos was shortened not by the expected 7 minutes, but by a staggering 32 minutes. Our tiny punch had the effect of a heavyweight boxer. We had successfully, undeniably altered the course of a celestial object. The dinosaurs had no defense. We now have the beginnings of one. But this is where the story gets complicated, and this is a debate we need to have. The DART mission was a proof of concept, but what if the target wasn't a tiny harmless moonlet? What if it was a dinosaur killer, a multi-mile wide asteroid discovered only a few years before a potential impact? The nudge technique only works if we have decades of warning. Hitting it early allows a tiny change in velocity to translate into a huge change in position millions of miles later. But what if we only have a few years? This leads to the controversial Plan B nuclear weapons, the Armageddon scenario. Do you think using nukes in space is a brilliant last resort or a terrifyingly reckless idea that could create an even bigger problem? Let us know your thoughts in the comments. This is a huge ethical and scientific debate. Furthermore, this new power brings with it a terrifying responsibility. The same technology that can deflect an asteroid away from Earth, can also in theory be used to deflect a harmless asteroid towards a target on Earth. We have just created the first potential planetary weapon. Who gets to control this technology? Who makes the decision to use it? The DART mission is a monumental achievement. It is a testament to human ingenuity. It is our first tentative step towards becoming a true and understanding why we need this technology and why it is so dangerous in our own hands is the next great challenge for our survival. We have witnessed the ultimate apocalypse. We have deconstructed the planetary execution triggered by a single rock from space, and we have just seen humanity's first defiant counterpunch, the DART mission. It is a monumental achievement, a moment that will be written about in history books for centuries to come. For the first time, a species on this planet has looked up at the heavens not in fear, but with a plan. Is a brilliant strategy, but it has one critical requirement: time. It only works if we have decades or even centuries of advance warning. A tiny nudge applied early enough allows the slow, patient work of orbital mechanics to create a huge miss millions of miles down the line. But what if we don't have decades? What if we discover a dinosaur killer on a collision course with Earth and the impact is only 5 years away? The nudge is no longer enough. This leads us to the terrifying, controversial, and very real Plan B, the Armageddon scenario. Using nuclear weapons to intercept it. This is one of the most heated debates in science. On one hand, it's our most powerful tool, a brute force solution for a brute force problem. On the other hand, it's incredibly risky. A poorly calculated nuclear blast might not deflect the asteroid, but instead shatter it into thousands of smaller radioactive shotgun pellets now heading for Earth on multiple trajectories. This is a huge dilemma. What do you think? Is using nukes in space a necessary last resort or a terrifying gamble that could make things even worse? Let's have a serious debate in the comments. The most important part of our planetary defense is not deflection, it is detection. Meet the real-life guardians of the planet, the scientists and astronomers of NASA's Planetary Defense Coordination Office, PDCO, and other similar organizations around the world. Their job is to be our planet's early warning system, the smoke detectors for a cosmic fire. Using powerful telescopes like Pan-STARRS in Hawaii and the Catalina Sky Survey in Arizona, these night watchmen systematically scan the heavens night after night, taking millions of pictures. They then use powerful computers to compare these pictures, looking for the tiny, faint dots that are moving against the background of fixed stars. These are the near-Earth objects, or NEOs. The task is monumental. They are trying to find and track over 90% of all NEOs larger than 140 meters, the size of a football stadium. It's like trying to find a dark piece of coal in the dead of night from millions of miles away. But they are succeeding. As of today, they have found tens of thousands of them. First time in the 4.5 billion year history of this world, one species has developed the ability to understand the rules of the universe, to read the threats written in the stars, and to forge its own defense. Our superpower isn't our strength or our size, it is our awareness. It is our relentless, insatiable drive to understand why. The story of the asteroid impact is the ultimate case study for why Zone 360. The asteroid is the ultimate dangerous threat. Understanding its kill mechanisms from the Shockwave to the impact winter is the ultimate why. And using that knowledge to build telescopes, to launch missions like DART, to create a planetary defense system, that is the ultimate form of survival. Understanding why the dinosaurs died is what will prevent us from sharing their fate, and that is the power of knowing why.